Main sequence stars. Main sequence stars are like middle-aged stars, such as our Sun. They shine steadily because nuclear fusion in their cores turns hydrogen into helium, releasing energy. These stars are balanced between gravity pulling them inward and energy pushing outward. They're stable and last a long time in this phase. Main sequence stars are common in the universe and provide the energy needed for life to exist on planets orbiting them. They're like the normal stars, spending most of their lives in this stable state before evolving into other stages. Red giants. Red giants are stars in their later stages of life, larger and cooler than when they were on the main sequence. As a star like the Sun exhausts its hydrogen fuel, it expands and cools, becoming a red giant. Despite their name, they can appear orange or even yellow. This expansion occurs because the star's core contracts while its outer layers expand outward. Red giants are much larger and brighter than before. Eventually, they shed their outer layers, forming a planetary nebula, leaving behind a dense core known as a white dwarf. White dwarfs. White dwarfs are the leftover cores of stars like the Sun after they have shed their outer layers in a planetary nebula. These cores are incredibly dense, packing the mass of a star into a volume about the size of Earth. Despite their name, white dwarfs can appear various colors, depending on their temperature. They are no longer undergoing nuclear fusion and instead cool down over billions of years, eventually fading into black dwarfs. Red dwarfs. Red dwarfs are the smallest and coolest type of stars in the universe. They are much smaller and cooler than stars like the Sun, with temperatures ranging from about 2,500 to 3,500 degrees Celsius. Despite their low temperatures, they can shine for trillions of years because they burn their fuel very slowly. Red dwarfs are very common in the universe, making up about 3/4 of all stars. Blue giants. Blue giants are massive and extremely hot stars that appear blue in color due to their high surface temperatures, often exceeding 10,000 degrees Celsius. These stars are much larger, hotter, and brighter than stars like the Sun. Blue giants have short lifespans compared to smaller stars because they burn through their nuclear fuel at a faster rate. They are rare in the universe but are important for understanding stellar evolution and the role massive stars play in shaping galaxies. Blue giants often end their lives in dramatic supernova explosions, leaving behind remnants such as neutron stars or black holes. Supergiants. Supergiants are massive stars that are even larger and brighter than giants like Betelgeuse. They can be hundreds to thousands of times bigger than the Sun, with surface temperatures that vary widely, often from 3,500 to over 20,000 degrees Celsius. These stars are rare and short-lived compared to smaller stars like the Sun, burning through their nuclear fuel at an accelerated rate. Supergiants play a crucial role in the universe as they contribute to the enrichment of interstellar gas and dust through stellar winds and eventually end their lives in spectacular supernova explosions, leaving behind remnants like neutron stars or black holes. Neutron stars. Neutron stars are the incredibly dense remnants of massive stars that have undergone supernova explosions. They are formed when the core of a massive star collapses under its own gravity, squeezing protons and electrons together to form neutrons. Neutron stars are incredibly dense, with a mass greater than that of the Sun packed into a sphere only about 20 kilometers in diameter. Due to their density, a teaspoon of neutron star material would weigh billions of tons on Earth. They have extremely strong magnetic fields and often rotate rapidly. Black holes. Black holes are regions in space where gravity is so strong that nothing, not even light, can escape from them. They are formed when massive stars collapse under their own gravity at the end of their lives, compressing their mass into an infinitely small point known as a singularity. The boundary surrounding the singularity is called the event horizon, beyond which no information or matter can escape. Black holes come in different sizes, from stellar mass black holes, formed from the remnants of massive stars, to supermassive black holes, found at the centers of galaxies and containing millions or even billions of times the mass of the Sun.